How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be taking a look at physical interface and cabling types. So this will be definitely important for any of you that are trying to understand all the different cable connections and things like that out there. So in our topology, I'm going to move this off screen real quick just so you guys can see everything. In our topology, everything we're doing is going to be Ethernet based. So all these connections are gigabit or Ethernet, 1 gig or higher. So we're not going to be dealing anything with fiber. We're not going to be dealing anything with, lease lines like frame relay or point-to-point protocol, anything like that. So the first thing we want to talk about is going to be fiber. And there's a couple different things that I want you to keep in the back of your mind when you're thinking about fiber. That there are two different ways that you can use fiber. The first of which is for structured cabling. So multi-mode fiber can be used for this, but single mode fiber is typically longer haul, over 500 meters, stuff like that. So when we talk about structured cabling, what I mean by that is the cabling infrastructure that connects all of your network areas together. So structured cabling would essentially be cabling that connects your switches together. So for example, if you had let me come down here and draw this out just so you guys have a visual representation. Let's say, for example, we have a very large campus area that we have to cover. So just imagine this entire screen is going to be the campus, and then we've got buildings, right? We got a building here, we got a building here, building here, building here. We got one really big building here. Okay? Inside this building, we might have a couple of IDF racks, in a couple different places like this. And then we're going to put our MDF here, main distribution framework. IDF is an independent distribution framework. So over here, this is where our ISP connections are. This is where our firewalls sit, all that good stuff. Well, what will end up happening is any cabling that is used to interconnect the squares together is what I would refer to as structured cabling. So if we have, and there's usually going to be a patch panel of sorts, so this will be my patch panel. So my ISP connections will come into here, and then they will also come out into my firewall. So what I'll do is I'll take these cables, and let me switch over to yellow. So what I'll do is I will draw yellow lines. This will be structured cabling, right? So we'll draw lines to each one of these. And then what will end up happening is, depending on the stretch or the range that or the distance you need to cover, you might have to run other connections. So this will be one very large campus. So you've got a large plot of land, let's say 10 acres, and then your cabling is set up that way. So for the sake of argument and simplicity, I'm going to use this cable. We'll connect this cable right here, but because between this building here and where the fiber comes in, let's say this is too far for multi-mode fiber. So we're going to have to go single mode. So I'm going to go and draw a line to here. But what I'll end up doing is these stretches here are, let's say they're half a mile for the sake of argument. Well, I have a fiber patch panel in this IDF, so I'll run a cable out to here, and I'll run a cable out to here. So the yellow is going to be our structured cabling, which means this is we contract a company to come in. They're the ones that run all the fiber up into the plenum spaces. So the plenum is going to be the area between the ceiling and the floor above us, and the walls, underneath the floors. That's the plenum space. PLENUM is plenum. So when you are dealing with plenum spaces, there's a couple things that you have to keep in the back of your mind, and that is fire rating. Especially when you're dealing with copper, there is plenum rated and non-plenum rated. Plenum rated typically means that there is going to be an additional insulation inside the actual Ethernet cable itself. So not the individual copper wires, but there's going to be like foil wrapped around it to help deal with EMI, electromagnetic interference. because there is a potential that you could be laying copper over like a fluorescent light or some other type of power source that could affect the copper cabling, things like that. Now, fiber doesn't typically need to deal with that because there's no electrical signal being sent over the wire. It's all laser and light. So that's what structured cable comes into play. And this is going to be your single mode fiber for long hauls. Now, within inside of a rack, and I'm going to switch my color over to sky blue. Within inside of a rack, what you would normally end up getting is multi-mode fiber. Now, multi-mode fiber is going to be connecting inside of a rack. Oh, actually, I'm going to switch over to white again. Let's say inside this room here we have a large rack. So this rack is actually over here. And inside this rack we're going to have a bunch of rack units, or RUs, as we like to, or U space. And what will end up happening at the top here, we'll have a top of rack switch, maybe whatever that might be. It might be a Nexus 9K, it could be a Catalyst 3K, it could be a Catalyst 9K. What the actual platform is irrelevant. But then below that, we could have other things. Like we could have, server 1, server 2, server 3, server 4. For simplicity, that's what we're going to do. And what I'm going to do is I'm going to connect these guys together. So the fiber will come in. Let me actually draw this out here. So the fiber comes in, and let's say for the top of rack switch, the fiber comes in over here and plugs into this switch. So that's going to be a long haul connection back to another part of the network. Okay, cool. Now that I have my long haul structured cabling brought in, the next thing is going to be to take the top of rack switch and to connect it down to my servers. So what I will do is I will use multi-mode fiber because I'm looking at potentially 10 gig, 40 gig, 100 gig, depending on the implementation. And I'm going to run multi-mode fiber down to the servers, like that. Now, I will show you what this looks like in a picture. I'll do a little bit of Googling and I'll show you what it looks like. But typically speaking, you're going to have a scenario where you're going to have an SFP, a small form factor pluggable. The SFP is going to be the module that goes into the port on the switch. So the switch is going to be like this, and there's going to be a module, an interface that is going to be open. And if you were to take the SFP is going to look, I'm going to do a very bad drawing of this, but the SFP is going to get inserted into here. And what will end up happening is the SFP is going to give you a place to plug your fiber into the switch. Because normally the opening on the switch is just an open port. You need to put something in that port for the fiber to plug into. So you plug the SFP into the port on the switch, and then you plug your fiber into the SFP. The SFP is your media converter, if you will. So it's going to plug that in, and you'll be on your way. So now your switch will be able to grab the communication off the wire and all that good stuff. So that's, just to recap, the yellow is what I'm signifying as structured cabling. This is not cabling you as the engineer are going to be responsible for. This is cabling you're going to be taking advantage of. So one question that I often get is, what's a great example of structured cable? How would I actually leverage that? And going back to my example over here, we have a very large building, and you might have a large area. Let's say you've got a very large cubicle farm. You've got a lot of users, and there's row after row after row after row of computers. You get desks, you've got computers, and you've got switches that are used to connect all that stuff together. Well, in order for the switches to be able to talk to the rest of the network, they might be several hundred feet away from another set of switches. So that communication, that cabling to get you from that switch stack to another switch stack, so from here to here, this would be this yellow cable right here, that's going to be your structured cabling. So this is going to be cabling that somebody else has already put in. You're not going to have to worry about that. Now, cabling with inside of the rack, you probably more than likely will have to deal with that. You might even be the sales engineer that is going through the process of figuring out, okay, how many fibers do I need? How many SFPs do I need? And ironically, I've seen a lot of bills of material, the actual how much equipment is being bought and how much does it cost. And I have very often seen where the actual hardware, the switches themselves, the licensing and stuff like that, will be dwarfed in the amount of money that it costs to buy SFPs and fiber, because cabling is going to be, it's a physical hardware, right? It costs a lot of money. So I've seen that many, many times be, one bill of material I saw just not too long ago was well over $1 million, somewhere in the neighborhood of 1.3, 1.4 million, and about 650, 700,000 of that was cabling. Now there were other things included with that, but there was the licensing was a good pair of that, support was a good portion of that, stuff like that. And then the hardware was only, I think, like 400. So you do your math on that, you're looking at a couple $100,000 in licensing and support costs. So it's not dramatically high on that side, but your cabling comes into play. So now that we've covered that and we understand how that piece comes into play, the simple way to remember this is if you are going over a very, very long stretch of distance, you're going to use single mode fiber. Typically, this is going to be running very, very hot, which means it's going to have a very high decibel output. So the dB output on the fiber will be very, very high. And because it needs to send a optical signal, whether it's laser or light, over this fiber over a very, very long distance. So that's the basics to it. I don't want to get too technical when how fiber works, but you also have multi-mode. Multi-mode is typically going to be for much shorter runs. Now there's another type out there called, and I'm just going to write twin-ax. I can't write W's for some reason. Twin-ax. Twin-ax is like a pre-terminated cable that comes in fixed lengths. So like 1 meter, 3 meters, 5 meters, stuff like that. And the idea with twin-ax is it's got the SFP and the fiber literally already built out. So it comes out of a bag, and all you have to do is plug in one side, plug in the other, and typically it's short enough to where you don't have to run it through the cable management. So there are times when you do, there are times when you don't. Now that we've talked about that, let me go ahead and clear my screen and pull up ZGoogles. So this is what I wanted you guys to be aware of. So you got the single mode fiber, and this is a good example of what this is going to look like. So let's click on here. Let me go ahead and get out of the way. So when we take a look at how this looks, the top one here, the yellow cable, is going to be your single mode fiber. And that is going to be a much longer, higher throughput difference, where the blue is going to be your multi-mode, and it's going to be a shorter distance, different cable type. So there is a whole bunch of OM grades, stuff like that, of what you can and can't do. So if you're into that, feel free to dive into it. So you can do single mode in a lot of places, but a lot of places you're going to see a multi-mode fiber, blue cable, comes in typical lengths. I mean, you can, it's easier to terminate, stuff like that. The other one is going to be twin-ax. Twin-ax cable. This is what twin-ax looks like, where if we were to look at it, it's literally going to be a pre-terminated. It comes, you got this little thing in the back here that you would literally pull, and it pulls the cable out. So if you look at it, I think these are QSFP by the looks of it. I can't really tell. But you got 10 gig, 40 gig, things like that. So the cable looks like that. SFP, is it a regular SFP? Is that a 1 gig? No, it looks like a 10 gig. Can I get any closer? Okay, this is a regular SFP. This is a 3 meter, 10 gig SFP plus 3 meter is what this. So it's a 10 gig. So when I made the mention of QSFP, is a quad SFP, which means it's 410 gig connections, so 40 gigabit. And there's some higher speed ones out there that are 100 gig and so on and so forth. So this is just one of those things where you would have to take that into consideration when you're looking at the cable and stuff like that. So let me show you what a QSFP looks like. QSFP. So it's going to look similar, but not quite the same. So this is a bad example. The cable width here is wider, and I don't know if you guys can see that or not, but it does say 40 gig QSFP, and 40 gig means that it's basically bonding for 10 gig. So, and then we'll look at a breakout cable, breakout cables. So this is what a breakout cable looks like. And a breakout cable, essentially what this does is this would plug in, it's going to break out 100 gig QSFP 28 to 425 gig SFP 28. So what you'll end up doing, if we were to zoom in here, this one here is going to go into the switch, and you're going to have 4 cables coming out of it. So kind of similar to the cat of 9 tails. And then these 4 will go into different servers. So you're able to take a 100 gig interface and break it down to 4 25 port connections. So I think that they also do this in a breakout cable. I think they do it in 4 by 10. Yeah, here's another example of this. Here, this is broken out. This is 4 by 10. Is it? Yeah, 4 10 gig. So it's a 40 gig QSFP into 4 10 gig SFP plus. So I've seen this done a lot too. And so this is another breakout cable, right? Because of the way that it's set up. But that's how that comes into play. But what I want you to understand is, if we look at SFP, the SFPs themselves, for example, the SFP, this is the SFP itself. So this guy right here, this is an LX. So what ends up happening is you take this side, and usually goes in this way. So this is a 1.25 gig SFP, 10 kilometer. So you would insert this going, so in this particular case with the way that I'll have to go this way. So you would insert this into the switch like that. So this part right here would go into the switch. Let's flip it over. So this is the copper contact that would go into the port on the switch. You take this little black thing off. Is it going to show me? Yeah, so you take the little black thing off right here. You take this black cover, which is protecting the actual optical connections, and then you would plug your SFP into here. This little blue thing, this is like a latch, and it comes down. And what will end up happening is you'll plug in, and then you'll plug the SFP into the port on the switch, and then you'll latch it closed with the little blue thing right here. That gets latched closed. Then you plug your SFP into it. Now what will end up happening is one side here, I don't know if you guys can see that right there or not, but one side will, if you were to like look directly at the port, like straight on at it, what you would see is one side would be lit up, one side would not be. The side that's lit up is your receive side. The side that's not lit up is going to be your send side. So what will end up happening is that what they refer to as polarity. So I've seen this a bunch of times where I've had to flip the polarity. So if I was to come back over here to this guy, no. Okay, right here. So what will end up happening is, let's see if I can give you an example of what that would look like. So this guy right here, it's a really bad pic. This might actually work. Can I zoom in on that? No. Can I look at multi-mode? Let me see if this will actually show me what I'm looking for. Okay, so this guy right here, this thing right here, these cables are actually individual, and then this little gray thing here is what keeps them together. So what sometimes will happen is when you're looking here, is your polarity will be flipped. So what you'll need to do is you'll need to come over here and you'll need to take this little connector thingy off. Is it going to show me? Yeah, so notice how this little clip right here, this little clip, these cables will be able to come out and you'll be able to swap these guys around. So you'll have to sometimes play with it. You'll have to literally look at it doesn't show you here, but if you look right here in the middle of this little output right here, sometimes there's these little white caps that come on the front of them, and you'll have to take them off, and you have to look at the cable. And as a matter of fact, sometimes I've had to take my phone out, depending on how strong the polarity is, and you'll have to look in, and you'll see a very faint red light in one side, and you won't see a light at all. So wherever you see a light, that's receiving. So what you'll have to do is you'll have to line that up. So if your interface is not coming up, you might have the send and receive sides flipped. So you're sending and you're receiving on the send, and then you're receiving and sending on the, you understand what I'm trying to say. The polarity is flipped. So, you've got to flip the cables. So if you take your cable out and you look at it and then you go to line it up, like you flip it upside down, and if your left side is lit up here but it's dark on this side, which means you're correct. If it's lit up on this side and lit up on this side, which means you're receiving and you're sending on the same connection, that's not going to work. So you have to literally take the cable out of the clip, B and A, and flip A and B, so that A goes to B and B goes to A. And then when you do that, that will allow you to line up. So if you look at the switch port and you see left is lit up but right is not, you look at the thing, your end of your SFP, and if left is lit and right is not, then you would need to, right? Left is lit, right is not. Left is not lit, right is. That means you're correct. But if they're flip-flop, if this side left is lit and right is not, which means you're trying to send and receive on the same pair or the same physical fiber, that's not going to work. So you literally have to break out this guy right here and then flip the polarity. And then so that when it's lined up, that your left is not lit, but you're on your switch port, the left is lit. That means you're receiving, and then you'll be able to plug it in, and then your interface should come online. Done that a whole bunch of times. It can be a little tricky until you've seen it for your first time, but that's essentially what you end up having to deal with when it comes to fiber in that respect. So that's basically how multi-mode and single-mode fiber works. There's a whole dedicated area of that when you get into things like SC and LC connectivity. That is not an area I am familiar with, so I've never really ever had to deal with it. But just so you are aware of how that comes into play, typically speaking, it's not that expensive, right? So you theoretically could, if you wanted to, run fiber in your home network, if you wanted to, go that far. SFPs, however, let's close this guy out. SFPs sometimes can be more expensive, but you have to find ones that are compatible with what you've got. This is a 1 gig SFP, 1.25. So what you'd have to do is, if you click right here, you can see it's SFP 1 gig LX31. So you just have to find a SFP that's going to be compatible with your hardware. Sometimes it could be a couple $100 for, especially for the higher speed ones. They get pretty expensive. So now we've covered that. Let's talk about copper. So we've all talked about copper, right? Ethernet, it's copper cabling. Everybody's happy. So let's take a look at copper. Let's look at copper Ethernet. So this is what I'm talking about when we say copper. So actually, let me click on this guy right here. So we have our this is going to be Cat 6 cable. Then we have this guy right here, where it's, you got your twisted pair. And then this is actually, why that is, Is this plenum rated? Yeah, it's insulated. So this is Cat 7 because it's insulated. Because I was like, wait, that looks weird. So what they've done here in Cat 7 is they insulate at all four pairs, and they insulate the individual pairs. So that's expensive. Well, not bad for the amount of it you're buying. But if we were to look at, say, Cat 6A shielded twisted pair, you have UTP and then you have STP. So you have unshielded twisted pair and shielded twisted pair. So this is a little 6-incher to connect things together. You got, untwisted pair. This is what you're normally going to see. But this is actually skinny. It's not as wide as it normally is. But, so this is what's going to go into your Ethernet ports. And as you can see here, they've got it twisted around. Sometimes you'll see this filled up, like they'll melt it so that it's locked in. The idea here is you want to try to get this cable as far into your RJ45 jack as you can to cut down on any type of noise. So just be aware of that as well. So that is one of those things where you just have to be cognizant of what it is that you're looking at. That is copper. There's really not a whole lot to go into. If you want to know more about copper, let me know. I can try to help you out, whatever. So now that we've covered that, the next topic of discussion is going to be connections. So let's talk about that. So you've got your connection types. You've got Ethernet shared media, and you've got point-to-point. So let me cover point-to-point very, very quickly. Point-to-point is going to be very, very easy to understand. Point-to-point is literally going to be stuff like this. R59 to XR44. This is going to be a point-to-point connection because there's only 2 devices on that Ethernet segment. So when I use the term Ethernet segment, that means how many a connection between 2 endpoints. So even though the subnet is /24 for simplicity, the point-to-point is a point-to-point connection. There's only 2 devices on that connection. Now, where it comes in to be Ethernet shared media, which is the other bullet point here, Ethernet shared media is going to come into play down here where you've got a bunch of PCs that are going to be needing access to the internet. So shared media implies that you're using a switch, a layer 2 switch, to do what they call multiplexing. Where, let's say for example, you get a normal internet connection, you get one public IP address. That goes into, that terminates on your modem or your router or whatever it is that you're working with. In my case, it terminates on a firewall. And then on the inside of that, you're going to have more than one connection. So you normally would never build out an environment where you only have one device being able to use the internet. Normally you'd be leveraging more than one device. Unless you live by yourself in a single, it's like you only have one, great, then the bandwidth is all yours. But in the event that you don't, let's say you're like me, you have a home lab, you've got family lives with you, so on and so forth. You've got more than one connection is needed. So anytime you have 2 or more connections that are needed in order for you to provide internet access or network access, that's going to be a shared media. The switch is your multiplexer. What do I mean by multiplexer? Very simple. A multiplexer is going to take a single connection and allow you to duplicate it multiple times. Hence the VLAN. The VLAN is where that's going to come into play. A VLAN, since we're talking fundamentals, is a virtual local area network. It allows you to take a device, like a switch, and logically break it up into multiple individual networks. So, for the sake of argument, we haven't done that here yet. We haven't gone through and done any configuration over here, but by default, there's one VLAN, and that's the default VLAN, or VLAN 1. So out of the gate, every interface on a Cisco switch and most other vendor switches is going to be VLAN 1. VLAN 1, if you plug all your devices into the switch and you do plug and play, meaning you're not going to do any configuration on the switch other than use it for connectivity, then what will end up happening is the switch will be your multiplexer. It will allow you to bring in one internet connection into a single interface on the switch into VLAN 1, and then any other port that's also in VLAN will be able to take advantage of that. So the switch is going to allow you to multiplex that internet connection up to 48 times. So up to 48 times means that you're going to be coming in on a non-downstream interface. So you're going to be coming in on one of the uplink ports on the switch. And then from there, you'll be able to plug things into it from there. So you'll be able to plug in, say, gig 00 through gig 048. You'll be able to plug in all 48 ports, and all 48 users will be able to get online. That's essentially what that means. So when we talk about Ethernet shared media, that's what we mean. Now, there are cases where it's not as straightforward, but for the most part, that is the case. So that is essentially what I wanted you guys to be aware of when it comes down to how this connectivity works. Point to point means that there's two endpoints. Well, there's two routers, two firewalls, whatever. And then shared media means that you are using Ethernet as the medium, the wire, to connect your PC to your computer, or your PC to your switch, or your PC to your phone to your switch, something along those lines, where you need to have some flexibility in the access level. And that's where shared media is. As soon as you hear the term shared, automatically think switch. And that'll be the caveat there. So, with that being said, ladies and gentlemen, I want to thank you guys for stopping by and hanging out with me in this video. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you in the next video.